We are seeing a shift in how professional assets are built. In programming and graphic design, tasks that once required manual syntax or pixel-perfect layout are now being generated through instructions that the machine translates into functional code. This doesn't mean human input is disappearing. It means the medium is moving. The creative work is clearly moving away from manual execution and toward the high-level logic that defines the final product. Video editors are now facing a similar transition. You can continue with the traditional process of dragging clips on a timeline, or you can begin managing the automated systems that are starting to handle the heavy lifting. For those working in the creator economy, long-term efficiency depends on this move. The end goal is to stop scrubbing through footage and start building the logic that generates the video for you. Traditional editing software is built on a heavy foundation. To render a scene, the computer has to process and calculate millions of individual pixels. It's a computationally demanding process, creating a lag between making a change and seeing the result. Programmatic video takes a different approach. Instead of treating frames as pixel canvases, it treats video as code. Adjusting a numerical value in the codebase updates the visual instantly. There's no waiting to render because the computer simply follows mathematical instructions. This text-based structure creates a bridge for AI. Because the video is defined by code, an AI agent can interpret natural language instructions and map them directly to the specific properties, like adjusting the video's scale, its precise angle of rotation, or the timing of the change. This method is the only way to match the turnaround times required by current content platforms. By removing the pixel processing bottleneck, editors can generate and iterate on complex visuals as fast as they can write the instructions. To start building video this way, you need a basic system environment. Most programmatic frameworks require your machine to have a runtime like Node 16 or Bun installed. For Mac users, the Codex plugin provides an entry point that doesn't require deep coding knowledge. It allows you to generate animations by typing out what you want in plain English. More advanced users can set up Claude code in their terminal. This configuration allows you to use an AI agent to architect entire workflows and manage complex project files through a single interface. Even without a background in software engineering, the setup is accessible. It allows creators to stop being limited by their software skills and start being limited only by the logic they can provide to the agent. Post-production usually begins with the most tedious task, hunting through raw footage to cut out silences, mistakes, and background noise. It is an administrative burden that takes hours of manual scrubbing. An AI agent automates this by running scripts like whisper.cpp. The system transcribes the audio, identifies the exact timestamps of every silence, and mathematically slices the footage at the correct points. This process can take an 18-minute raw file and condense it into a tight, seamless 6-minute cut in seconds. Automation doesn't mean giving up creative choices. Because the result is a codebase, you can still go in and manually adjust granular keyframes for the position, scale, and color of any element in the scene. By delegating the repetitive grunt work to the machine, the editor is free to focus on the high-level pacing and the narrative flow of the final video. Model Context Protocols, or MCPs, let the AI agent communicate with external services. With the Playwright MCP, the agent autonomously visits websites, capturing and importing screenshots as video assets. The Mapbox MCP generates 3D travel routes across topographic maps, turning geographic data into custom animations. By integrating the ElevenLabs MCP, the agent can analyze the project's transcript to automatically generate synthesized voiceovers and layer in appropriate sound effects. These protocols connect the video editor to web-scale tools, allowing a single creator to pull in data and assets that would normally require a full production team to source and animate. Currently, the programmatic video space is split between two primary coding architectures. The Remotion framework is built on React. It uses the same dynamic logic that powers complex web applications, making it highly effective for data-driven video. On the other side is Hyperframes, which is built on HTML. This is the foundational structural language of the entire internet. Using HTML allows hyperframes to easily generate motion graphics and split-screen layouts that look like native web interfaces. This HTML structure also makes it possible to build click-and-drag workspaces on top of the code. It creates a bridge where you can have the precision of code and the intuitive feel of a visual editor at the same time. The outputs of this technology are already being used to create complex 3D data visualizations and transparent, interactive user interfaces that feel integrated into the video. The role of the video editor is changing. The focus is shifting from the technical task of moving pixels to the directorial task of architecting the code that defines the vision. You can begin experimenting with these frameworks today, opening a terminal and learning these programmatic